In this lesson, we're going to be looking at an example of conservation of momentum involving collisions, where we're going to be looking at a stream of particles, in this case, bullets, pinging into a target. So it's like a machine gun firing bullets. That's so many bullets per second hitting a target. And we're going to be looking at what happens to the change in momentum of the system, as well as the kinetic energy change in the system, and talking about bullets and what it is that bullets do. So initially we are told there's a stream of pellets, bullets in this case, moving and at 1,100 meters per second. Each bullet is relatively low in mass, 0.0038 kilograms. They are fired into a relatively large, by comparison to the mass of the bullet, 12 kilogram block. And we are asked to calculate the speed that the block will acquire after it has absorbed 15 of these bullets. Well, since the block is at rest, doesn't have to be, certainly in other problems, other examples, it could have been in motion to the left or to the right, but in this case we were told it's at rest. So since the block is at rest, all of the initial momentum of the system is with the bullets. So we have 15 of the bullets, each of them with a momentum, mass of the bullet times the velocity of the bullet. In this case it is positive. Again, in other problems they could have rearranged it and fired the bullets backwards. But we have the bullets going forward, so we have the total momentum of the bullets, 15 times the mass of the bullets times the velocity of the bullets, all of which we are given. The final momentum of the system is now the combined mass of all 15 bullets and the block, the 12 kilograms, and multiplied by then the velocity of the bullet block system now as it moves forward. And when we make that calculation, we get that the block would be moving forward at 5.2 meters per second. So based on what we've done, I think a relatively easy calculation. But the real interest in this problem, I think, comes from looking at the change in the kinetic energy of the system and what it is that bullets do and what they were designed to do. The initial kinetic energy is all the bullets. We have 15 bullets, relatively small masses, but bullets move at very high speeds. So these 15 bullets all together would carry a kinetic energy of 34,485 joules. We saw that even with conservation of momentum in place and no other energy losses, that the final kinetic energy of the system, look at this, is only 163 joules. So that's with no friction to stop the motion of the block going forward. That's just the bullets embedding into the block, the bullets coming to a stop, and the block continuing to move. Well, let's think about what happened to that 34,485 joules that was initially there. Where did it go? Well, for better or for worse, it went into doing what bullets do. It went into smushing, smashing, crunching all the material of the block as they come to a stop. So, as you can see from this drastic release of energy into the block, bullets are very good at what they do. And that is why this technology, bullet technology, has been around for hundreds of years, right? So the first gunpowder and bullets was invented many, many years ago, and we still have guns and bullets because of this change in kinetic energy that we just calculated, being so drastic as bullets embed into targets. So, kind of a simple example mathematically, but I thought it was important for you to understand, bullets and what it is that they do, so I included it as a separate example. And we have one more example to do before we go on to a new topic.